Okay, so we've already looked at quadratic functions in general form, which you can see here, and in standard or vertex form, which you can see here. The general form, the a value tells us which direction it opens in, and the c value tells us the y-intercept. In the vertex form, the a value still tells us which direction it opens, and then the h and k are the coordinates of the vertex. We also know that the minimum or maximum is going to be equal to k, and the axis of symmetry is going to be x is equal to whatever the h value is. The k is also what's going to appear in our range when we're writing out the range. The last form we're going to take a look at is this factored form, where a, or f of x is equal to a times x minus m times x minus n, where a can't be 0 once again because we would make it a non-quadratic if a was 0. So first, let's take a look at a couple of different examples of this. So remembering that if in the original form it's x minus m, x minus n, then if it was minus 2, then m is just going to be what comes after the minus. If it is minus 8, n is going to become what comes after the minus. When we graph it out and then search for the zeros or the roots of our function, we can see that the x-intercepts occur at 2 and 8. The y-intercept occurs at 16. And the axis of symmetry occurs when x is equal to 5. In the second case, when I have x plus 2, well, if I'm going to flip the sign in the middle here, it's actually the same as minus negative 2. So m is actually negative 2. N is going to be positive 6. The intercepts occur at negative 2 and 6. The y-intercept occurs at negative 12. And the axis symmetry is when x is equal to 2. In the next example, m is negative 2, and n is negative 6. The intercepts are at negative 2 and negative 6. The y-intercept is at positive 12, and the axis symmetry is when x is equal to negative 4. In the next case, there is no brackets in here, which means that they've eliminated the m from there, or the m is just going to be equal to 0. The n is equal to positive 4. The intercepts occur at 0 and 4. The y-intercept occurs at 0, and the axis symmetry is when x is equal to 2. And in the last case, m is going to be negative 8, n is going to be positive 10. The intercepts occur at negative 8 and 10. The y-intercept occurs at negative 80, and the axis symmetry is when x is equal to 1. What are the commonalities? Well, we can see the x-intercepts are the m and n values. The y-intercept is the product of m times n. And the axis of symmetry is when x is equal to the two intercepts added, or m plus n divided by 2, because it's halfway between the intercepts, like we've learned in a previous lesson. So, following what we've already learned, the x-intercepts are going to be m and n, the y-intercept is going to be m times n, and the equation for the axis of symmetry is x is equal to m plus n divided by 2. What if we change the a value so the a value is no longer just 1 like it was in all the previous cases? Well, here I'm going to wind up with an a value of 2, m value of 5, and an n value of 2. When I graph this out, the x-intercepts occur at 5 and 2. The y-intercept occurs at 20, and the graph opens up in a U shape. In the second case, a is 4, m is negative 3, and n is positive 2. The intercepts occur at negative 3 and positive 2. The y-intercept is at negative 24, and this one also opens upwards. For the third example, a is 5, m is 10, and n is negative 3. The x-intercepts occur at 10 and negative 3, or negative 3 and 10, and the y-intercept occurs at negative 150, and this one still opens upwards. For the next example, the a value is negative 3, the m value is 0 because we're missing this second bracket, and the n value is going to be negative 2. The x-intercepts are at 0 and negative 2. The y-intercept occurs at 0, and this one actually opens downwards. For the next example, I have negative 10, negative 1, and positive 3. X-intercepts at negative 1 and 3. The y-intercept is at positive 30, and this one also opens downwards. And for the last one, a, where I just have this negative here, we know there's always an imaginary coefficient of 1, so it's actually negative 1. M is positive 10, and n is negative 10. The x-intercepts are at 10 and negative 10, and the y-intercept is going to occur at 100, and this one will also open downwards. So, what do we see here? Well, the x-intercepts, just like in the last case, were m and n. The y-intercept is no longer just m times n. The y-intercept is actually going to be a times m times n, the product of all three of these values. If a is positive, the graph opens up and has a shape like this. If a is negative, it's going to open down and has a shape like this, which is the exact same as what we saw in our general form and our standard or vertex form. And you can see that all three of them have that lowercase a, and the value of a is always the same.